Hello, today we're going to go over some problems that you might encounter on your test two. So right now we're in week 10 of MAT 205. Tonight we're going to go over a few practice problems. I have selected the top 5 missed concepts that I'm seeing on test two. After you watch this video and go through these 5 problems, remember to work on your ALEKS practice test. And also keep in mind that your highest attempted score on that practice test becomes your homework grade for the week. Okay, so here's our first problem. And let me see if I can make this a little bit nicer to see. All right, this is the most missed concept that I've been seeing over the last 2 or 3 years. So here's an example of this concept. The average cost for 2 people to go to a movie is $22. The average cost for 2 people to go to a movie is $22 with a deviation of 5. Assume the cost is normally distributed. Okay, so as soon as I see those words, the normal distribution, I'm going to draw myself a normal curve. All right, and then I'll continue. Find the probability that at any given theater, the cost will be more than $32 for 2 people to go to the movies. Use the empirical rule. So we know the empirical rule tells us that 68% of our data will fall within 1 standard deviation of the mean. We know 95% of data falls within 2 standard deviations of the mean, and 99.7% of the data falls within 3 standard deviations of the mean. Okay, so we're going to use this rule, this empirical rule. Okay, so let's sketch this out. Average cost for people to go to the movie is 22 bucks, so average always goes in the middle. Okay, it deviates $5. All right, so that means plus and minus $5. So let's go out, let's see here. If this is starting point is 0, let's go out 1, 2, 3 deviations to the right, and -1, -2, -3 deviations to the left. All right, so take a moment, pause the video, and sketch this out. All right, so hopefully you added 5, another 5, and another 5 to go up to 3 deviations to the right or above $22, and then subtract 5 from 22, subtract 5 to come down 3 deviations below the average. Okay, let's do some shading. Find the probability that any given theater, the cost will be more than $32. So more than $32. So more than 32, it's going to be the probability of somewhere in here. Okay, so let's go and let's put our empirical rule over top. So we know from -1 to +1 deviations, there's a 68% chance, because that's 34 plus 34 will add to 68, right? Percent chance that data will fall there. If we come out to 2 deviations, according to the empirical rule, we'll add another 13.5% here and another 13.5% here. Okay, so that's from here to here. That's going to be 95%. Okay, if we go out a little further from deviation 2 to 3, we've got 2.35% here. From -2 to -3, 2.35% here. And then in the little tiny tails is 0.15%. 0.15%. Okay, so we just want to know what these 2 pieces add up to be. That's the probability that 2 people would go to the movies and it would cost more than or greater than $32. So we're going to add 2.35% plus 0.15%. Okay, so our answer is there's a 2.5% chance that the 2 of us go out to any given theater and it's going to cost us more than $32. Okay, hope that helps with that. That is the most missed concept. So you are allowed 1 piece of paper of notes, front and back, I would definitely make sure that you have the empirical rule and all of the percentages written out, because you're allowed to have that on your test. All right, another concept that's the second most missed concept is a question like this. Find the area under the standard normal curve. Okay, let's draw a standard normal curve. To the left of z equals -2, use there's that empirical rule again. All right, so let's sketch out the empirical rule. All right, we start at the center, that's usually your mean, and you can go up 1, 2, or 3 deviations higher than the mean. You could also go below. Okay, so the empirical rule tells us that 68% falls within 1 deviation. That's 34% and 34%, and that adds to 68. We know from here to here, it's another 13.5%. That's how we get to 95% here. And then off in the, like kind of in the tails here, you have the 2.35 here percent and 0.15% here. So 0.15% here, 2.35% here. So if you were to add this up, 0.15 and 2.35 and 13.5 and 34 and 34 and 13.5 and 2.35 and 0.15, the whole thing is 100% in percentage or 1 in decimal form. Okay, they want to the left of -2. Okay, let's shade that. Okay, so they want 2.35% plus 0.15%. Now, so that's going to be the same as the last problem that we just worked on. But here's the difference. It's in the way you want to deliver your answer. So when they use the word probability, like they did on that other question, we want to use percentage. When they use the word area, right, we want to use decimal. So you would divide this by 100 and get 0.025. Okay, that's the area, the piece right there. Now, according to the empirical rule. Oops, let's see if you can see that. There you go. 0.025. This is what you want to answer. Now, if you happen to put 2.5 into ALEK's program on your test, it's going to mark you incorrect. But of course, you know, I go back and review anything that's missed on all of my students' tests. So if I see that, I'll know that that's what you meant. But just keep an eye out. That's what they mean when they say area. So percentage for probability, percentage for probability, both are P's. And then area, they want decimals. All right, let's look at the third most missed concept. Okay, so you're probably seeing a trend by now. These concepts that are missed are all about the empirical rule, or at least these top three are. So we definitely want to make sure that you have that empirical rule somewhere in your notes. You're allowed to have that, you know, that one page of, I call it your cheater sheet for your test. Okay. So suppose that the average cranial capacity for men is 10 cc's or cubic centimeters, and that it deviates 200 cubic centimeters. Assuming that men's cranial capacities are normally distributed, so there's our curve, distributed, complete the following statements. Approximately 68% of the men have cranial capacities between blank and blank. Okay, so we know between -1 and +1 deviations from -1 to 1, that's 68%. All right, so that's what they're looking for. So they want what's going to be those cranial capacities. So in the center, we know it's 1010, according to this, and then we can go up 200. So this would be 1210. And if we subtract 200, we'd be at 810. So 810 goes with -1, and 1210 goes with +1. So 68%, if we were just to randomly measure the average cranial capacity for men, they would be between 810 cubic centimeters and 1210 cubic centimeters. That's if they're asking for 68%, right? If they ask for higher, 95%, we're going to have to subtract another 200 and add another 200. But for now, we're going to go between 810 and 1210, since they're just asking about 68%, which is one standard deviation away from the mean. Okay, approximately blank, so this is going to be a pull down, of men have cranial capacities between 410 and 1610. All right, so that's going to be somewhere down here and somewhere above here. So let's keep adding. So 1210 plus 200 would be what? 1410. And if we add another 200, that'd be 1610. Okay. If we subtract 200 from 810, we're at 610. That's 2 deviations. And 410 would be 3 deviations. Okay, they're asking about between 410 and 1610. Okay, so 410 is here, 1610 is here. So those are 3 deviations from the mean. So remember, the rule tells us one standard deviation, the empirical rule, tells us 68% of data will fall between that. 2 standard deviations is 95%, and 3 standard deviations is 99.7%. So that's between here and here is 99.7%. So that is going to be our pull down here. If they ask for cranial capacities between 610 and 1410, well, that would be 95%, right? Because so from here to here, it's 95%. If they already did ask us between 810 and 1210, that's 68%. So hopefully that's going to help you refresh yourself before your test if you get this concept. Okay, the fourth most missed concept, again, it's the empirical rule. Okay, so we definitely see a pattern here. You definitely want to nail the empirical rule because there's, I think, 15 questions on test 2, and there could be potentially 4 of them so far that use the empirical rule. All right, find the area. Okay, so area under the standard normal curve. Draw that out. To the right of z equals -1. Okay, we got this. So let's mark this out. So to the right of z equals -1 is they want to know the area here. Now notice they use the word area instead of probability. So we're going to want to give this in a decimal form, not a percentage form. All right, so we know according to the empirical rule, 34% are here and here, 13.5% here, 2.35% here, and 0.15 there. So we just need to add those up. So 34 and 34 and 13.5 and 2.35 and 0.15. I could probably break out my calculator here, but I'm being lazy. Okay, so I think that's 84%, which makes sense, right? If half of this is 50% and we add another 34%, actually that would have been easier for me to do that. And some of you might have already been saying to yourself, why isn't she doing that? Well, it just didn't occur to me at this second. But yes, if this is 50%, we can add on 34% and we could easily get to that 84%. Now make sure to divide that by 100 and put 0.84 as your area. And that is the area to the right of z equals -1. That is your area. And remember, if you put 84, I'm going to come back and fix that if you missed that on Alex, because Alex program will probably tag you on that. Okay, we have one more concept that is missed a lot. Okay, we have the fifth most missed concept, and that is on classifying when researchers or statisticians take samples from the population. So here it looks like there's three scenarios. Let's go through them one at a time. So counselors at a college want to poll students about how much time the student spends studying. Which of the following best describes a systematic sample? So systematic sample is something like, let's just say you're at a manufacturing um, plant and they are manufacturing belts, right? And the belts are coming down like the conveyor belt here. And let's just say they sample every, I don't know, 50th belt. Okay, that's called systematically sampling. So let's look through here and see if any of those sounds like it could be um, where they're selecting people, I guess students here, every 10th student or every 100 students. The counselors use a computer program to draw 50 students at random and select these students. Every set of 50 students is equally likely to be drawn by the computer program. Well, that's not it because that's random sampling, which is a great way to sample, but not what they're asking us to do here. The counselors form two groups of students based on the number of classes the students are taking. Then the counselors select 25 students at random from each group. All right, so you're probably thinking that's either cluster or stratified, and you'd be right. It's one of those two. Still not systematic. The counselors take a list of students and select every fifth student until they get 50 students. There it is. All right, so fifth. So systematic, look for something that's got a TH on it. Okay, a botanist at a nursery wants to inspect the health and plants at a nursery. Which of the following best describes a, convenience sample? Okay, so remember convenience sample is just one that's easy for the researcher to access. It's kind of a lazy way of sampling. It's not going to produce something random. All of the plants that are in one particular room at the nursery are easily accessible. So the botanist selects 64 plants in this room. Um, that could be it. Let's just look at the other ones. We'll put a question mark here. The botanist takes a list of the plants and selects every fourth plant until 64 plants are selected. Well, that's systematic. And hopefully you recognize that because of that TH. The botanist assigns each plant a different number using a random number table. He draws 64 of those numbers at random. Then he selects the plants assigned to the drawn numbers. Every set of 64 plants is equally likely to be drawn. All right, so that's the gold standard of sampling. That's that random sampling. So it's definitely going to be, I guess we would call this A, because the plants in this nursery room are easily accessible. So instead of going through this process or even the systematic process, this was a lazy way for them to get a sample. It's not going to produce good data. This is always a bad way of sampling. Okay, we have organizers at a conference want to survey attendance about the registration fee. Probably wanting to ask them, do you think it was too much, too little? What is the following, which of the following best describes a, they're going to go for stratified sample of attendees. Okay, I want you to read through these three choices and decide which one do you think is stratified. Remember, stratified is a little different than cluster. So think through this and then come back and we'll talk. All right, if you're back, hopefully you crossed this one off. The organizers select the first 56 attendees who registered for the conference because they were easily accessible. Now that is convenience sampling, so we don't want that. All right, there's two more to choose from. The organizers form groups of 8 attendees based on the day the attendees registered. Then the organizer randomly chooses 7 groups and selects all of the attendees from those randomly chosen groups. Or the organizers form 7 groups of attendees based on the attendees' employment status. Then the organizer selects 8 attendees at random from each group. Okay, so stratified. You're going to have a researcher that separates into strata, normally by some shared characteristic. So for in this case, the shared characteristic is their employment status. Here's the other thing that separates stratified from cluster. They select 8 attendees at random from each group. So stratify separates by some sort of characteristic, in this case, their employment status, and then they choose some from each strata. So it's definitely going to be this one. Cluster is very similar. Cluster, you're still going to separate, but then they're going to pick clusters and grab all from the chosen clusters. So let's go back. The organizers form groups of attendees based on the day the attendees registered. You could probably argue that that is a way of separating them by some sort of characteristic. Cluster normally separates by geography. Okay, in that case, this is not so much geography, but here's what separates this. The organizers then randomly choose 7 groups, so separates, then picks clusters and selects all of the attendees in the groups. That's what makes that cluster. Okay, so hopefully this helped you, and I wish you good luck on test 2. Take care. Um, and was there anything else I wanted to say? No, I think that's it. Just the usual. You got to use the Respond as lockdown browser. You got to have your photo ID. You can use scrap paper and 1 page of notes. One thing I do wanted to add is make sure to have your printed area tables. Okay, this is very important. You might need those. Can't have your phone or other computer help aids. You got 2.5 hours to complete the test. There's 15 questions, and make sure you take it in one sitting. You can't close it out and return back. So that's also very important. And then remember, after the deadline has passed, which is usually Sunday night at midnight, you can go to the assignments area and Alex, click on your test 2 score to review your submission. And then just give me a few days to go through everyone's tests and just see if I can give you partial credit on things like we talked about earlier, where let's just say you put in 35%, it should be 0.35. Okay, so those I'm going to go in and give you credit for. All right, good luck. Bye. Thanks for watching.